Nuclear physics is the field of physics that studies atomic nuclei and their constituents and interactions. Other forms of nuclear matter are also studied. Nuclear physics should not be confused with atomic physics, which studies the atom as a whole, including its electrons. Discoveries in nuclear physics have led to applications in many fields. This includes nuclear power, nuclear weapons, nuclear medicine and magnetic resonance imaging, industrial and agricultural isotopes, ion implantation in materials engineering, and radiocarbon dating in geology and archaeology. Such applications are studied in the field of nuclear engineering. Particle physics evolved out of nuclear physics, and the two fields are typically taught in close association. Nuclear astrophysics. The application of nuclear physics to astrophysics is crucial in explaining the inner workings of stars and the origin of the chemical elements. The history of nuclear physics as a discipline distinct from atomic physics starts with the discovery of radioactivity by Henry Becquerel in 1896 while investigating phosphorescence in uranium salts. The discovery of the electron by J. Thomson a year later was an indication that the atom had internal structure. At the beginning of the 20th century, the accepted model of the atom was J. Thomson's plum pudding model, in which the atom was a positively charged ball with smaller, negatively charged electrons embedded inside it. In the years that followed, radioactivity was extensively investigated, notably by Marie Curie, Pierre Curie, Ernest Rutherford and others. By the turn of the century, physicists had also discovered three types of radiation emanating from atoms, which they named alpha, beta, and gamma radiation. Experiments by Otto Hahn in 1911 and by James Chadwick in 1914 discovered that the beta decay spectrum was continuous rather than discrete. That is, electrons were ejected from the atom with a continuous range of energies, rather than the discrete amounts of energy that were observed in gamma and alpha decays. This was a problem for nuclear physics at the time, because it seemed to indicate that energy was not conserved in these decays. The 1903 Nobel Prize in Physics was awarded jointly to Becquerel for his discovery and to Marie and Pierre Curie for their subsequent research into radioactivity. Rutherford was awarded the Nobel Prize in Chemistry in 1908 for his investigations into the disintegration of the elements and the chemistry of radioactive substances. In 1905, Albert Einstein formulated the idea of mass-energy equivalence, while the work on radioactivity by Becquerel and Marie Curie predates this. An explanation of the source of the energy of radioactivity would have to wait for the discovery that the nucleus itself was composed of smaller constituents, the nucleons. In 1906, Ernest Rutherford published Retardation of the Alpha Particle from Radium in Passing Through Matter. Hans Geiger expanded on this work in a communication to the Royal Society with experiments he and Rutherford had done, parsing alpha particles through air, aluminum foil and gold leaf. More work was published in 1909 by Geiger and Ernest Marsden, and further greatly expanded work was published in 1910 by Geiger. In 1911-1912 Rutherford went before the Royal Society to explain the experiments and propound the new theory of the atomic nucleus as we now understand it. The key experiment behind this announcement was performed in 1910. At the University of Manchester, Ernest Rutherford's team performed a remarkable experiment in which Geiger and Marsden under Rutherford's supervision fired alpha particles. Nitrogen-14 consisted of a nucleus with 14 protons and 7 electrons, and the nucleus was surrounded by 7 more orbiting electrons. Around 1920, Arthur Eddington anticipated the discovery and mechanism of nuclear fusion processes in stars in his paper The Internal Constitution of the Stars. At that time, the source of stellar energy was a complete mystery. Eddington correctly speculated that the source was fusion of hydrogen into helium, liberating enormous energy according to Einstein's equation A equals mc2. This was a particularly remarkable development since at that time fusion and thermonuclear energy, and even that stars are largely composed of hydrogen, had not yet been discovered. The Rutherford model worked quite well until studies of nuclear spin were carried out by Franco Rossetti at the California Institute of Technology in 1929. By 1925 it was known that protons and electrons each had a spin of plus or minus 1/2. In the Rutherford model of nitrogen-14, 20 of the total 21 nuclear particles should have paired up to cancel each other's spin. And the final odd particle should have left the nucleus with a net spin of 1/2. Rossetti discovered, however, that nitrogen-14 had a spin of 1. In 1932 Chadwick realized that radiation that had been observed by Walther Bothe, Herbert Becker, Irene and Frederick Joliot-Curie was actual.